All right, we're zooming way, way down today into a literal microscopic battlefield. We are taking a fascinating look right inside the tiny, intricate, and surprisingly chaotic environment of the chicken gut. Now, I know it might sound incredibly niche, but what happens in this specific microscopic ecosystem has massive real-world implications for global health, the safety of the food on our plates, and the future of how we actually fight disease.
Okay, let's dive into this. For decades now, our go-to weapon against agricultural diseases has basically just been antibiotics. But we are facing a massive global food safety challenge. We've relied on these drugs so heavily that the pathogens are outsmarting us. They're evolving into these highly resistant superbugs. So the big question we desperately need an answer to is this: can we control dangerous foodborne pathogens using natural biological solutions instead of just dropping antibiotic bombs every single time? So here is our roadmap for this explainer. First, the salmonella threat. Second, the probiotic experiment itself. Third, using metagenomics to look inside the gut. Fourth, restoring microbial balance. And finally, reducing those food-borne pathogens. Let's get right into it.
Section 1. The salmonella threat, a microscopic villain.
So our specific target today is Salmonella typhimurium. It is a sneaky bacteria that stunts growth in chicks and then just silently hides out in older birds, eventually contaminating our food supply. For a long time, the agricultural industry used subtherapeutic doses of antibiotics in animal feed just to suppress these infections. But honestly, this scorched earth approach is totally failing us. It literally breeds resistant superbugs and completely annihilates the host's natural defenses. We need to start deploying guardians rather than just destroyers.
Section 2. The probiotic experiment, testing the guardians.
To test a true biological alternative, researchers wanted to see what would actually happen if they deployed good bacteria to the rescue. They set up this meticulously controlled study, raising 196 newly hatched broiler chicks to test if these microscopic allies could genuinely fortify them against a deliberate, targeted pathogen attack. The researchers tested two very different teams of probiotics. In one corner, we've got ProQ, which is a locally isolated Thai blend of lactic acid bacteria. You can think of them as these sensitive but highly supportive caregivers. And then, in the other corner, we have TopGut, a commercial strain of Clostridium butyricum. These guys are spore formers, making them tough, resilient, and totally capable of surviving some really harsh environments. So, the crucial point here is the battle plan itself. Step 1, rear the chicks. Step 2, divide them into groups and supplement their diets with either ProQ, TopGut, or traditional antibiotics as our baseline comparison. And then step 3, the challenge. The researchers deliberately introduced a highly virulent strain of Salmonella known as ST2 directly into the chick systems just to see which defense strategy actually held up the best.
Moving to Section 3, metagenomics, inside the gut, reading the DNA blueprint.
Now, to truly see who is winning this microscopic war, the researchers brought out the big guns: shotgun metagenomics. Instead of trying to culture individual bacteria in a petri dish like the old days, this technique takes a sample from the gut and sequences all the DNA present at once. It's essentially conducting a complete, high-resolution census of the gut microbiome. We get to see exactly who is living there and in what numbers. And this census provides some pretty incredible visual proof. What's really fascinating is looking at how these microbial families and phyla shift over time, before the challenge, 1 day after, and then 7 days after. Notice how the groups treated with probiotics show this rapid reorganization of their microbial communities. They managed to preserve diversity and stabilize the whole environment compared to the unmedicated infected chicks. It's like watching a city rebuild itself in real time. The metagenomic analysis revealed some very specific heroes emerging in the probiotic groups. First, lactobacillus populations completely surged. These are protective acid producers that literally make the gut inhospitable to salmonella. Then we saw Akkermansia, our mucus-loving barrier builders that fortify the gut wall. And specifically in the TopGut group, there was a massive enrichment of Parabacteroides. These guys act like microscopic firefighters, just totally soothing inflammation. Section 4. Restoring microbial balance, healing the ecosystem.
But, knowing who is there is really only half the story. We absolutely need to know what they were actually doing to heal the ecosystem. The functional pathways reveal that these probiotics weren't just taking up space. We see a huge boost in oxidative stress defense, alongside massive increases in amino acid and carbohydrate metabolism. They were actively changing the entire chemistry of the host.
By reading the DNA, scientists saw that the probiotics essentially gave the chicks superpower shields. They produced enhanced levels of catalase to neutralize damaging free radicals caused by the infection. They boosted amino acid metabolism to help repair tissue, and they maintained carbohydrate energy pathways, which allowed the chicks to extract vital nutrients and produce short-chain fatty acids, absolutely crucial for cellular energy and fighting off pathogens.
Finally, Section 5, Reducing Foodborne Pathogens, the Nuanced Reality.
This brings us to the core essence of this experiment, testing if we could actually reduce the salmonella load. By quantifying the DNA using real-time PCR, we see a really nuanced biological reality. Take the top gut probiotic, for example. There's this huge spike on day 1, mainly because those tough bacterial spores needed time to germinate in the gut before they could fight back. But by day 7, the pathogen load drops massively, lower than all the other challenged groups. Once established, the probiotics forcefully push the salmonella out.
Now let's compare that to the traditional antibiotic group. Interestingly, the antibiotics actually promoted a high level of good lactobacillus, but despite that, the salmonella load remains stubbornly high at day 7. Why? Because the antibiotics caused dysbiosis. They totally altered the oxygen and chemical balance of the gut, creating this chaotic environment where salmonella could still thrive. The probiotics, on the other hand, restored deep microbial harmony, leading to that massive pathogen reduction we just talked about. And this brings us to the ultimate conclusion of this study, and it's a really vital shift in how we think about disease. Using probiotics is an incredibly powerful tool, but listen, science isn't magic, and in a living, breathing ecosystem, absolute zero just isn't the reality. There will almost always be trace amounts of a pathogen. However, probiotics create a balanced ecosystem that drastically reduces the foodborne pathogen load in chickens. It keeps the host healthy and makes our food supply much safer, completely avoiding the dangerous side effects of antibiotics. It's truly a massive paradigm shift from a war of pure eradication to a strategy of smart cultivation. Which leaves me with a question for you. If a balanced, thriving microbiome is the ultimate shield against disease in poultry, how might we rethink our own daily diets to cultivate our own microscopic guardians? Thanks so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you on the next one.